Welcome back, my dear students. Welcome back. स्वागत है बेटा आप सभी का. You're all welcome. कैसे हो बेटा आप सभी लोग? How are you all? Very happy good evening बेटा. अनुष्का विश्वास, सुस्मित नंदी, शिवा तरुण and all. Very happy good evening बेटा. देवर्ष अग्निहोत्री. Confirm me everyone बेटा. Audio, video crystal clear to all of you. Okay. Fantastic, mind blowing, super. Clear, sir. So now we are in beta lecture number 24. Reactors and Numericals Part 4. As you all know, decided Gaurav Shrestha sir from Engineers Institute of India with 14 plus years of teaching experience as GATE Chemical Engineering Educator, author, multiple GATE top rank, super rank like this year rank of AIR 43. So can you tell me beta what is this? ये क्या है? What is this? Can you tell me beta? What is this? Are you able to recognize it? Yeah. Yeah, it looks like double pipe heat exchanger, na? Yeah, but it's PFR. It's PFR. It's PFR. That means PFR are nothing but simple pipes. Simple pipes. So today, especially we will focus on this PFR. Okay. And before that, just I want to revise few things to you. Revision. Till now, you had seen first one batch reactor design equation. I hope in batch reactor all concepts are crystal clear. And the second one you had seen CSTR. And for CSTR, the design equation that you had seen was V by FA naught, and that equals to XA upon minus RA, or you can also write it as V upon FA naught is equals to XA final minus XA initial for any given CSTR. Okay, initial for that one. Okay, for that reactor, not for all reactor initial. That means not if you are writing here XA3, so don't take here XA1. If this is XA3, then this is XA2. If this is XA2, then this is XA1. If this is XA1, then this is XA0. Okay, so these design equations we discussed in detailed manner. So I hope everyone feeling comfortability with these all topics. Okay, Shiva Tarun sir, in batch reactor V is a mixture volume and in CSTR V is reactor. Is it correct, sir? Yeah, beta, absolutely correct. Shiva Tarun, it's absolutely correct. That's why here this V is not a function of epsilon A. Independent you can't write, because if you're going to change epsilon A, then after calculation it will change. Okay, but here you can write one beautiful thing with this one, that at t is equals to 0, at t tends to any value, to any value, v will remain v. You can't change this. Out in this whole equation, only the term that can be a function of time is this one. And I will tell you in detailed manner soon how to deal it in a separate lecture beta. Okay, so here it can be for 0, and it can also you can write for epsilon A not equal to 0 here also. So how to write it, don't worry, I will discuss in detailed manner soon. Okay, so today's topic is the plug flow reactor. Before starting this topic, I want to discuss few fundamentals from fluid mechanics. I hope everyone is familiar with laminar flow and turbulent flow. Beta, you know it. What is laminar flow? What is turbulent flow? And the velocity profile in a pipe flow. In pipe flow, velocity profile for laminar and turbulent. ये सभी को पता है? Please, everyone, tell me, beta. Everyone, please confirm me. If the profile looks like this, parabolic, so this is the profile for laminar flow. ये सभी को पता है ना? एक बार जरा सब लोग बताओगे हमें. If you don't know, still no need to worry. You will see derivation in फ्लूइड मैकेनिक्स. आप फ्लूइड मैकेनिक्स में इसका डेरिवेशन डिटेल्ड मैनर में देखोगे. Okay, this is the second one, and one fluid you will see in fluid mechanics, Bingham plastic. This is the profile for laminar flow. This is the profile for laminar flow. This is the profile for turbulent flow in a pipe. Turbulent flow. And here flow for Bingham plastic. Bingham plastic. Okay. Now just to focus here, beta. Here clearly you can see, if you want to check, the magnitude of velocity is max at the center, and when you are going towards wall, velocity decreases, and at the wall velocity is 0. That is no slip condition. Okay, if the wall is stationary, the velocity is 0. If wall is moving, then the fluid velocity you can write just equal to velocity of that wall, because no slip condition is there. In turbulent flow, you can see mostly near the center you can see a flat profile. You will get a flat profile near the center. And in Bingham plastic, when you are moving towards center, velocity increases, and near the center you can see a flat profile is there. So if you are doing to check what is the meaning of this flat profile, then this type of flow is known as beta plug flow. That means here near middle plug flow. Plug flow near middle. Near middle. If someone asks you in a complete pipeline, plug flow is a possible or not possible. If someone asks you in full pipeline, plug flow is possible or not possible, then clearly you can say, but a plug flow is not possible. That's why this reactor that you are dealing here, I'm not writing anything like ideal plug flow reactor, but this is the ideal one. If someone asks you just they're writing plug flow reactor, then by default you are dealing ideal plug flow reactor. If no non-ideality data is there, then you have to assume ideal plug flow reactor. And in reality there is no ideal plug flow reactor. आपके पास ideal plug flow reactor है नहीं. आप reality में कभी भी definitely some non-ideality must be there. You will be able to find it there. Some non-ideality. So, sir, because sir, you told me, sir, ideal is not possible. Then, sir, why we are studying this plug flow reactor? Beta, because you will only able to understand the non-ideality concept or actual conversion that you are going to get in this plug flow reactor only after getting familiar with this ideal plug flow reactor. In examination, they can ask you from ideal plug flow reactor as well as from non-ideality. So we will cover non-ideality later. Okay, with a separate chapter, non-ideality in reactors. Then we will see non-ideality in CSTR, we will see non-ideality in PFR, because you are here for CRE, chemical reaction engineering, and whenever you are going to react anything, you need a vessel, and the name of that vessel is reactor. So definitely आप पूरे सब्जेक्ट में कभी reactor से पीछा नहीं छुड़ा पाओगे. Every time the reactors will be, you will be able to find in most of the questions. Okay. So please tell me, laminar, turbulent and Bingham plastic flow is crystal clear. Now if someone asks you, no, please draw a profile for plug flow, then what is the profile for plug flow? See, simple flat profile. Simple flat profile. What does it mean? What does it mean? That means the magnitude here, velocity magnitude here, the magnitude of velocity here, the magnitude of velocity here, everywhere velocity is same. This type of behavior is known as plug flow behavior. This is plug flow, beta. Sir, why is plug flow near middle? Why is plug flow? Beta, the answer is present in fluid mechanics when you will see Bingham plastic, pseudoplastic, dilatant plastic, Newtonian fluid, non-Newtonian fluid. You will see there. Here, this is not the topic of this CRE. So here I can't give more time to that topic, beta. That is from fluid mechanics, from FM. ये FM का part है, beta. You will see in fluid mechanics. ओके, जस्ट आई शोड यू एनालॉगस नेचर, जस्ट एनालॉगस नेचर के लिए वो थोड़ा हमने डिस्कस कर दिया। फ्लूइड मैकेनिक्स में आपको डिटेल में पढ़ाया जाएगा, सो नो नीड टू वरी बेटा। ओके, so plug flow meaning what? Plug flow meanings that the velocity here, the velocity is not a function of radius. It is not going to depend upon radius. At any radius, velocity will remain same, and you know it is not possible in ideal manner, because no tube is available with zero friction. Definitely some friction is there in the tube, and also at the wall no slip condition is there. So if some fluid is at a stationary, then definitely it is going to resist the above sliding layer. ओके, अगर कोई फ्लूइड खुद रुकी हुई है तो ये अपने ऊपर से जाने वाली अपने ऊपर की लेयर को थोड़ा रोकेगी, और वो थोड़ी धीरे हुई तो वो अपने ऊपर वाली को थोड़ा और धीरे करना चाहेगी. So these all behaviors you will see in detailed manner in fluid mechanics, like temperature distribution, where you are going to see heat transfer. For velocity distribution, separate subject is there, that is fluid mechanics. Only here a part I used to tell you why it is known as plug flow reactor, because the behavior here is plug flow. The flow behavior is plug flow, and not only the behavior of flow, concentration, temperature, everything is not going to depend upon radial direction. Okay, so if we are dealing with a plug flow reactor, what is the meaning of plug flow reactor? Wait, I will tell you. First, see, first point, it contains a single continuous long tube. Sir, why sir you are telling long tube? Why not short tube? Short tube can also be used, but in short tube residence time is very less. That's why in industry the reaction is not happens in reality in short tubes. Why? Because the residence time is very less and the reaction is not going to complete there. So definitely you have to give enough time for reaction. So long tube must be there, or maybe lots of tubes you can use in parallel, that is PFR in parallel. I will uh, discuss this topic, PFR and CSTR, parallel, series, and along with graph in separate lecture. Okay, after completing the first step of CSTR, PFR, everything. So simply it is a single tube or tube banks. That means in your examination they can ask you, a tube is there and the reaction is happening there. The flow behavior is plug flow. No need to worry. Still you are dealing a plug flow reactor. In examination, one question asked in last 5 year you can find it. I didn't remember actually here. I will show you later that question. Just you have to solve that and you have to tell me what is the length of that tube and the concept behind that plug flow reactor. Okay, so we still discussed only few fundamentals. I want to ask you again beta, everything is crystal clear till now? Can we proceed? वेरी हैप्पी गुडिंग बेटा, अनुष्का विश्वास, किया दास, सभी का स्वागत है बेटा. एवरीवन वेलकम. टेल मी माय डियर स्टूडेंट्स, कैन वी प्रोसीड? नो डाउट्स एट ऑल? वेरी इजी. Now, what is the meaning of plug flow reactor? Now, plug flow, you know what is plug flow? What you know well, what is plug flow? Now, what is a plug flow reactor? See, suppose a reaction is happening there, and that reaction, suppose A is forming R. Simple reaction I am writing, A is forming R. Okay. Initially, suppose you are feeding A here as 100 mole per meter cube. Suppose definitely when it start flowing inside that reactor after some path, some A converted, so now 90A, here maybe 85, here maybe now 82A remained, here maybe now 77A remained, here now maybe 60A remained. So overall at the exit suppose 52A remained, so 48% conversion is there, simply you can see. Okay, now if I'm asking this 90, this concentration 90 mole per meter cube is here, so what should be in the same radial direction here? You have to say sir same, it's 90. Here, sir, same 90. Sir, here, same 90. Here, same 90. But if you are moving in this direction, see beta, this direction is known as radial direction. ये आपका radial direction कहलाता है. This is known as radial direction. And my dear students, this direction is known as axial direction. Axial direction. So now you can say that in a radial direction, can you tell me in radial direction, infinite mixing or zero mixing? Which statement is correct? In a radial direction, infinite mixing or zero mixing? Please tell me everyone. In radial direction, infinite mixing or zero mixing? Infinite or zero? In radial direction. I'm asking in radial direction. Very good. So I want comment from everyone. Everyone. Anushka Viswas zero mixing. Shiva Tur infinite mixing. Susmit Nandi infinite mixing. Okay, very good. Other students beta Mehna, Ayush, everyone infinite. Ayush, very good. Kiada zero mixing. Mehna typing. Waiting for your comment beta Mehna. Infinite mixing. So beta the right answer is infinite mixing. Kiadas and Anushka Viswas. See beta. Uh, yeah, they were Shagnihotri. Very good beta. Here I am telling you 90, here also 90, here also 90, here also 90, here also 90. When it is possible, when radially you are mixing it infinite, that means total max possible mixing is there. So radially, there is no gradient present. Gradient present only axially. Are you getting it, beta? Are you able to understand? Kya Das and Anushka Viswas? If yes, then please write crystal clear, beta. Got it, sir. Very good. And beta Kya Das, you also? Is it clear, my dear student? Because you are telling radially there is no gradient, and no gradient means infinite mixing. You can say infinite. Yes, sir, clear. Very good. So this is also better because it is in reality it is not possible. In reality it is not possible. Not only this concentration, my dear student. If I am writing this concentration, okay, suppose I am telling temperature, suppose in degrees Celsius I am telling temperature. Here temperature, suppose I am telling 70, and suppose this is exothermic reaction. Okay, and suppose I am telling that wall is adiabatic. Suppose I am telling wall is adiabatic. Then adiabatic VFR. Wall is non-adiabatic. Non-adiabatic VFR. Don't worry, this is also a separate chapter. Adiabatic and non-adiabatic reactors. Isothermal and non-isothermal reactors. These are also your future chapters. Okay. So here wall is adiabatic. If I am telling wall is adiabatic, what does it mean, beta? That is no heat can go outside. No heat can go outside. Now again I am asking beta, here if the temperature is 70 degrees Celsius, can you tell me at the exit side the temperature is more than 70 or less than 70? More than 70 or less than 70? This is also one GATE PYQ. Hmm? One mark question asked in GATE examination. Temperature is more than 70 or it's less than 70? More than. Very good. Because the reaction is exothermic, so heat is evolved there and you are not going to remove any heat, so heat is going to accumulate it in that mixture. So along with path the temperature is going to increase. Oh, ulta bana diya. Along the path the temperature is going to increase. Okay, temperature is definitely more than 70. Okay, very good. Suppose I am telling a typical value here, like this is now 95 degrees Celsius. Suppose 95 degrees Celsius. Just I am giving a typical value. If here it's 70, here also 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 it's 70, everywhere it's 70. Here also 70 is 95, 95, 95, 95, 95, 95, 95, 95. That means axially temperature is also not a function of. Here velocity is not a function of radial direction. Temperature is not a function of radial direction. Concentration is also not a function of radial direction. That means radially nothing is going to change. But if you are moving in axial direction, all can change, but not velocity because it is a plug flow. So velocity still can't be changed in any direction. Okay, plug flow. It's plug flow behavior. But these two will change. So this is the meaning of plug flow reactor. Now, just to focus on the second point, beta. Clearly, clearly, it is a steady state reactor because the accumulation within reactor is there, but the rate of accumulation within reactor will be zero. Will be zero. Okay, that means anytime the feed in, the amount, the kilogram, the mass in must become equal to mass out. So this is a steady state reactor, and mass in mass out. What is the meaning of mass in mass out? That means continuous reactor. It is also continuous flow reactor in which now focus on this line beta, in which composition varies along path, along with path. So in this direction, this is your path, this is your path. So what is path? You can also write composition varies along axial direction. You can also write like this, along axial direction or with axial direction, but doesn't change with time. What is the meaning of this? Doesn't change with time. See, suppose you are checking here the value of concentration. It is 82, suppose, at time t1. You know, at time t2 and at any time, if you are checking the concentration here at this point, it will remain 82, 82, 82, 82, 82. So it is not going to change. It is not going to change. So that's why here writing doesn't change with time. Every time here 100 concentration enters, and when this 100 reaches this position, now it becomes 82. So here 82, every time whenever you are going to check there, it will remain 82. Whenever you are going to check here, it will remain 85, even at t1 or after 1 hour, after 5 hour, or after any time, after any time. So clearly composition varies along the path, but not with time. बट नॉट विद टाइम. ये टाइम के साथ चेंज नहीं हो रहा, स्पेस के साथ भले चेंज हो रहा, इट इज गोइंग टू चेंज विद स्पेस बट नॉट विद टाइम. At that space every time whenever you are going to check here, suppose it's 75, 77, 77, 77, 77, and if you are checking along this direction, everywhere 77 at time t1, time t2, time t3, time t4, anytime. But when you are moving in this direction, now it can change, it can change. Okay, like for reactants it will decrease, for product it will increase, along the path, it will increase. Okay, so tell me beta, till now crystal clear? Can we proceed? फटाफट फटाफट जल्दी से बताएंगे बेटा सभी लोग. Everyone able to understand? So tell me, axial mixing zero, axial mixing is zero or infinite? Tell me. Very good. Crystal clear. Then tell me this answer. Axial mixing is zero or infinite? Axial mixing is zero or infinite? क्या बात है. Everyone correct बेटा, everyone correct. It's zero, because if they are going to mix axially also, then the complete PFR will be uniform, and clearly you can see this is not uniform. In CSTR, inside CSTR, at any point whenever you are going to check what is the value of concentration, what is the value of temperature, inside that CSTR, at any position, any space, it was not a function of space, not a function of time, but here it is a function of space. ये space के साथ change हो सकता है, and if space के साथ change हो रहा है, like here see it's 90, here it's 85, here 82, here 77, here 60, at the exit it's 52. So it is going to change along the axial direction. So axially there is no mixing, and this is also known as back mixing. So here in assumptions, you can write the first assumption, my dear students. No, or write in this manner. Radial mixing. If someone asks you, it's infinite. If someone asks you axial mixing, it is also known as back mixing. So it's zero, and you can also write no back mixing here. no back mixing, no back mixing here. Okay, so these are the general assumptions you can write here in case of PFR, that is plug flow reactor. That is plug flow reactor. Okay, now here you can see this is your one element that just I'm assuming here inside that reactor. Suppose this is your element, this is your element, and just you want to check what is happening with this element. और suppose रुको इसे 2D में ही देख लो, 3D अगले डायग्राम में बनाएंगे. So if this is your element, so beta in this element this direction is, as I told you, radial direction. This is radial direction and this direction is axial direction. ये axial है और वो radial है. So axially there is no mixing and also there is no back mixing. That means once the reactant pass any space, now it can't go back. एक बार आगे बढ़ गया तो बढ़ गया. Because you can see, my dear students, velocity profile. Simple. There is no backflow. There is no backflow. Okay. So once it passes that respective space, now अब ये वहां पे वो reactant वापस वहां नहीं जा सकता. Okay. One more thing. What is this? This is your CSTR. Just I want to show few things. Suppose this is your CSTR. बेटा ये आपका CSTR है. And in this CSTR, suppose these 5 molecules enters here. One more, and this is suppose exit point. One molecule path may be like this, direct exit. The other molecule can go like this and now exit. The other molecule may enter from this position and it go like this, like this, like this, like this, like this, like this, like this. In after traveling this much path, now exited. Other also doing like this and passes. And the other one, suppose here and now here, here, zigzag, now passes. So inside CSTR beta, the residence time here you can see residence time. Can you tell me residence time is same for all particles? Yes or no? Residence time is same for all particles. Is it correct? Is it correct? Here residence time for each particle is no. Yeah, absolutely correct. Residence time is different for each particle. Different for different particles. For different particles. All particles entering at the same time. But when you are checking here in plug flow, see, these 5 enters here. Now, after some time when we are checking, their position is at time t1 here, at time t2 their position here, at time t3 their position here, at time t4 their position here, and now exited. At time t5 they are exited, and all exited at the same time. Now again next 5 molecules enters. They are also going to travel in a similar manner. So whenever you are going to check for any particle, the residence time is not going to change. When? In the case of PFR. In the case of PFR. So here you can write residence time same for all particles. Same for all particles. Are you able to understand beta? ये समझ पा रहे हो ना? Everyone able to understand, my dear students, that here residence time is same for all particles. Here it is different for all particles. ये हर एक पार्टिकल का रेसिडेंस टाइम जो CSTR में होगा वो अलग अलग होगा, बट इन केस ऑफ PFR it is same. It is same. Okay, very good, fantastic, mind blowing, super. And one more thing beta, whenever you are discussing like this beta, so this is your ideal CSTR, this is your ideal PFR. I'm not writing anything, but what we are discussing, we are discussing every time. Whenever I'm not writing, that means I am dealing ideal. That means I am dealing ideal one. Okay. What is non-ideal, sir? You will be able to understand non-ideal only after understanding ideal part well. आप आइडियल पार्ट को जब बहुत अच्छे से जान जाओगे तभी तो नॉन आइडियल को पढ़ पाओगे. दैट्स व्हाई फर्स्ट वी आर डीलिंग विद आइडियल. Okay, in examination also they are asking lots of questions from ideal as well as from non-ideal. Now fill in the blanks. Fill in the blanks. In ideal PFR, all reactants molecule having, here you have to fill same residence time. Same residence time. Okay. Now it gives dash conversion then CSTR with equal size volume. You know, because in PFR you can see the particles are not going to back mix and all particles having the same time inside this reactor. So generally whenever you are seeing here, at the entry point concentration is more, at the exit point concentration is less. But here inside this CSTR, every time the concentration will remain same in complete reactor. That's why you will find it that PFR will give you more conversion. PFR will give you more conversion in than CSTR. But exceptions are there. You know exceptions, beta. Exceptions क्या आपको पता है इसमें exceptions क्या है? कब ऐसा होता है कि CSTR कन्वर्जन ज़्यादा दे दे PFR से या बराबर दे दे PFR के? इज इट पॉसिबल? इज देयर एन एक्सेप्शन? That means when you are taking same volume, same size CSTR PFR, you will get more conversion in PFR. Adiabatic reactor, your CSTR will also adiabatic here. Shiva Tarun, CSTR भी adiabatic है. PFR भी adiabatic है. In PFR also heat is going to accumulate there. Anything else? Because the reaction may be exo and do na yaar, Shiva Tarun. Don't know? Then write R in comment section. If you don't know, then write R in comment section. Neeraj typing. Shiva Tarun typing. R. Okay. Very good, beta man. Absolutely correct. So, valid. Valid. This statement is valid for positive order reaction. Positive order reaction. Exception. What is exception here, beta? What is exception? Exception number 1. Negative order reaction. For negative order, V CSTR will be less than VPFR. आपको छोटा CSTR वो कन्वर्जन दे देगा, वही कन्वर्जन PFR बड़ा चाहिए होगा. The second assumption, for zero order reaction. If zero order reaction is there, my dear students, CSTR and PFR in both cases the volume will remain same. For the case of zero order reaction. So please write this validity and exception for this point number 1. For this point number 1, validity and exceptions, please write it. And if any doubt, just ask me. You know, beta, suppose you are dealing with CSTR. Suppose here CA naught, a typical value I am giving. Suppose this is 10. Okay. And suppose the conversion here, I am writing that 90% conversion is there. So definitely the CA will be here 1, 90% converted. 90% converted. Simply suppose A liquid is going to convert it to R liquid. This is the reaction, simple reaction. So beta, if here this is 1, then inside reactor everywhere the concentration will remain same, no? 1, 1, 1. Everywhere it will remain 1. Sir, can you explain point 1? Yeah beta, Shushmit, that point 1 explaining it again. Again वही explain हम कर रहे बेटा यहाँ पे. So अगर 10 यहाँ घुसता है और यहाँ पे आपका 90% कन्वर्जन होता है तो यहाँ पे आपका 1 आएगा, और ये 1 आया मतलब रिएक्टर के अंदर हर जगह कंसंट्रेशन एक ही था. If entering at 10, if 90% conversion is there, so definitely the exit concentration will be 1 mole per meter cube. This is 10 mole per meter cube. So every time the concentration will be 1, 1, 1, 1, 1. It's 1. It's 1. Every time it will remain 1. But here in this case, if you are putting CA naught is equals to 10 here, okay, then here it may be 9, here it may be 8, here it may be 7, Okay, here it may be 6 and moving in this way, moving in this way, moving in this way. That means inside reactor, everywhere the concentration is not 1. The concentration is, mostly you can see it's more than 1. Mostly you can see it's more than 1. In the most part of the reactor, the concentration is more than 1. Now, suppose this is your rate expression, K Ca minus 1. Or you can write K by Ca. Can you tell me? When Ca will decrease, Ra will increase, na? See, which out of these two, which reactor you are going to handle at lower concentration inside the reactor? Can you tell me, beta, is it PFR or CSTR? I know everyone able to understand. It's CSTR. So that's why when negative order is there, CSTR is advantageous one, but negative order is a rare case. Like inhibition reaction, and these rare cases are there. So no need to worry. Whenever in examination they are going to ask, they will mention it. So just write it, and if they are asking any uh, question, then they will give rate expression. Just handle after putting that simple differential equation, you have to solve it. Okay, आपको simple differential equation को solve करना होगा. Just mathematics is there. Okay, but if positive order reaction is there, then what is advantageous for us? हमारे लिए तब क्या advantageous होगा? Suppose it's KCA. Now if CA decreases, it also decreases. That means here mostly for positive order the rate is less by this CSTR, but here rate is more, little bit less. When you are moving along with reactor, the rate will be decreases there in PFR में रेट आगे बढ़ते हुए डिक्रीज होगा, बट CSTR में पूरे के पूरे रिएक्टर में ही रेट आपको कम मिलेगा. Are you able to understand? That's why here it gives valid for positive order and exception negative order. Then you will get advantageous for CSTR, because CSTR में जगह जगह आपका conversion जो है वो concentration depend ऐसे कर रहा है that low concentration is going to favor the rate expression. So if low concentration where it is possible, it's possible in this CSTR for same initial concentration. If zero order reaction, what is the meaning of zero order reaction here? K Ca raised to power 0. It decreases, it increases, nothing going to change it. It will remain constant. It will remain constant. So now, what factor is going to affect rate now? Only and only this temperature dependent. So now it is dependent upon temperature, not concentration. So that's why ideal CSTR or ideal PFR both will provide you same to same conversion. Is it crystal clear to all of you, beta? क्या अभी आपको clear हो गया क्या ये? Just tell me everyone, beta. Is it crystal clear? Can we proceed, my dear students? Can we proceed? Crystal clear, sir. Very good, very good. Everyone crystal clear. Can we proceed? Okay. Now, can you fill here? It gives same, more, less. What you are going to fill here? Conversion as batch reactor for same residence time. यहाँ क्या fill करोगे? Tell me. It gives same conversion. Yeah, very good. Very good, as batch reactor for same residence time. Because you know na, you know, see, these all 5 particles are moving in this way, and all particles stays same time for in that reactor. So if you are going to do handle this in simple batch reactor, suppose this is your batch reactor, batch no in no out, just you filled it, and suppose here T5 is suppose 10 second. So if you are going to use here residence time as 10 second, then if here the exit concentration is suppose 0.01, here also the after this time the concentration will remain as same 0.01. So because here everything is going in similar manner like batch reactor. In batch reactor also, you know, concentration is not a function of space, but it is function of time. So that time here is a function of space. At this time t2, if you want to check what is the composition here, it will remain same as you are seeing here at this position in this PFR. At time t3, what is the concentration here? It will remain same at this composition, what the composition here in this PFR. In Hindi if you want to fill it, बेटा, see, इसके अंदर में जो भी हो रहा है टाइम t1 पे यहाँ पे जो कंसंट्रेशन रहेगा, आफ्टर टाइम t1 जब यहाँ कंपोजिशन एनालाइजर को लगाओगे देखोगे वही कंपोजिशन मिलेगा। टाइम t3 के बाद इस पोजीशन तक इसमें पहुंच गया है इस रिएक्टर में, तो यहाँ जो भी कंपोजिशन होगा, जब आप इस पूरे रिएक्टर में कहीं भी चेक करोगे बैच रिएक्टर में, तो आपको भी वही कंपोजिशन मिलेगा। सो यू कैन सी हियर द कंपो इफ यू आर गोइंग टू गिव सेम टाइम, ऐसा फ्लूड का यहाँ फ्लो रेट आप सेट करो कि ये अंदर उतना ही देर रुके जितना देर रुक रहा है, उतनी ही देर के लिए अगर हम बैच रिएक्टर में इसको लगा दें तो कन्वर्जन आपका चेंज नहीं होगा। इफ you are going to give the same time here in batch reactor according to this flow rate, the time that the reactant is going to spend here in this PFR, if you are going to allow them the same time in this batch reactor, the composition at that time, or you can say the conversion at that time, will remain same. So it gives same conversion as batch reactor for same residence time. For same conversion, the size of CSTR is larger than PFR, but here also validity is n should be greater than 0. If it is less than 0, then you can see here already written by me. Okay, so on this slide the theory that discussed by me, is it crystal clear? Or if any doubt, then you can ask me, beta. Ask me, beta. Still waiting for your comments. आराम से रिवाइज कर लें. Sir, why batch reactor has same conversion as PFR? Because beta in PFR, Susmit Nandi, in PFR you're also going to provide the same time. आपने बैच रिएक्टर में क्या देखा? यू आर हिंदी लर्नर, सो जस्ट फील इट इन हिंदी. आपने बैच रिएक्टर में देखा कि जो आपने रिएक्शन मिक्सचर डाल दिया, वो पूरा पूरा रिएक्शन मिक्सचर एक तरह से आपके प्लग फ्लो का कोई एक एक्सियल डायरेक्शन का एक स्पेस रिप्रेजेंट कर रहा है, जहाँ रेडियली आप वही सारे मिक्सचर को सपोज रेडियली फैला दिए हो और अब उस रेडियली देख रहे हो, जैसे जैसे आगे बढ़ रहा है चेंज होता जा रहा है. तो बैच रिएक्टर में तो यही हो रहा है ना यार. जस्ट ट्राई टू फील इट बेटा. Will it give same conversion as CSTR? No, 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 no. For CSTR, the conversion will be more. Okay, just you had seen na Ayush, CSTR से compare करोगे तो for every positive order reaction you will get more conversion in PFR. Okay. And if you want to again feel it in simple line, then again I am repeating. In CSTR you had seen, listen carefully, in CSTR you had seen uniform low concentration inside reactor. That is perfect mixing is there inside your reactor, and it's going to ensure you that it operates at exit concentration because perfect mixing is there. So jo under the concentration that is available inside the reactor will remain same at the exit of the reactor. That means reactant concentration reactant concentration instantly drops. Reactant concentration instantly drops from CA0 to CA. CA0 at entry, CA at exit. Instantly drops. That means the reaction is now going to occur entirely going to occur at low CA. RA is equal to KCA, and that CA reaction mixture CA that is inside the reactor. Okay, that's why RA is going to decrease there. That's why for same volume you will get less conversion in case of CSTR, whereas in PFR you had seen gradual decrease in concentration. Fluid elements flow like plugs, that is plug flow, with no axial mixing, and here concentration gradually decreases. Concentration gradually decreases from C0 at entry and Ca not at Ca out or Ca at outlet. So you can see in case of PFR, significant portion of your reactor now going to experience high concentration. So if high concentration, it is going to maximize RA. So that's why for same size, PFR is going to give you more conversion. In Hindi, if you want to fill it, CSTR में आपने देखा एक पैक कंसंट्रेशन ड्रॉप हो रहा था, जिसकी वजह से इंटायर जो रिएक्शन हो रहा था वो लो कंसंट्रेशन पे हो रहा था, जो आरए को घटाएगा, और आरए घटेगा मतलब ए समय के साथ धीरे धीरे कंज्यूम हो रहा है. अरे धीरे धीरे कंज्यूम हो रहा है तो कन्वर्जन कम ही ना मिलेगा. वेयर इन केस ऑफ पीएफआर, सिग्निफिकेंट पोर्शन जो आपने देखा पीएफआर का वो हाई कंसंट्रेशन पे ही वर्क कर रहा है. हाई कंसंट्रेशन तो अगर पॉजिटिव ऑर्डर है तो ये आरए को बढ़ाएगा, रेट को बढ़ाएगा. तेजी से डिसअपियर मतलब क्या हुआ? मतलब साफ है कि यहां पर आपको कन्वर्जन ज्यादा मिलेगा. नाउ आई होप बेटा एवरीवन फीलिंग टोटल कंफर्टेबल. हिंदी इंग्लिश बोथ लैंग्वेजेस यूज्ड. सो आई होप प्लीज टेल मी बेटा एवरीवन फील्ड इट. सबको फील हो गया? कैन वी प्रोसीड? Okay, and you can also see this with the help of graphical result. For positive order reaction, the graph that you will get will be concave upward. Okay, so I will show you after modeling, or you can say after deriving design equation of PFR with the help of graph also. You can feel it, you can see it that for the same volume, the PFR is going to give you more conversion in comparison to C star, but wait, for general cases means for positive order reaction, that is order more than 0. If order is 0, both will remain, both will give you same. Why same? This thing again I will show you with the help of graph, but after design equation. The graph is possible after derivation of design equation. Okay, बोलो सभी को मजा आया? All clear? मस्त, सुपर, माइंड ब्लोइंग. चलो, वेरी गुड, वेरी गुड. So next heading, my dear students, mathematical modeling of PFR, that is design equation of PFR. अभी हम लोग डिजाइन इक्वेशन के बारे में पढ़ेंगे बेटा. जस्ट लाइक सी एस टी आर, यू हैड सीन वी बाई एफ ए नॉट इज इक्वल्स टू एक्स सी अपॉन माइनस आर ए, और एक्स से 2 माइनस एक्स से 1 अपॉन माइनस आर ए 1. Okay, now here the same type of design equation we are going to derive for PFR. This topic is also known as mathematical modeling of PFR. Okay, mathematical modeling of PFR. In similar manner, we are going to take material balance here. यहाँ भी हम क्या करने वाले हैं बेटा? यहाँ भी हम लोग material balance ही लेने वाले हैं. Okay, now एक बार और आपको एक शो करना चाहते हैं. See, this is your batch reactor. At time t1 is equals to 5 seconds. The same batch reactor here you are seeing at time t2 is equals to 10 seconds. The same batch reactor you are seeing at time t3 is equals to suppose 17 seconds. Okay, the same batch reactor you are seeing at different time. And this is one beautiful plug flow reactor. Okay, in out, every time in out is there. Now see again same point, you want to show it because maybe when some student going to see recording they will feel difficulty. तो एक और एग्जांपल लेके आपको फिर से क्लियर देते हैं. अनुष्का उसका सर, फॉर सेम रेजिडेंस टाइम कन्वर्जन इन पीएफआर विल बी मोर देन इन बैच रिएक्टर, हाउ इज इट सेम देन? बेटा अनुष्का, फॉर सेम रेजिडेंस टाइम कन्वर्जन इन पीएफआर विल बी सेम एज इन बैच रिएक्टर. सेम लिखोगे फॉर ऑल जनरल केसेस. Exceptions everywhere, exceptions are there, but for general cases we are discussing here. Okay, Anushka, is it clear? See, that's why I told you ना, I want one more example. एक और example चाहिए था. हमको पता था कुछ बच्चों के दिमाग में भी पड़ा है. आपने कह दिया क्रिस्टल क्लियर, बट अभी आपको डाउट है, ऐसा लगा हमें, फील हो गया था आपके क्रिस्टल क्लियर लिखने के बाद भी फील हो गया था. Now just focus here. Suppose but at t1, at t 5 second, the same reactant here enters and reaches here after 5 seconds. Okay, and reaches here after 10 seconds and reaches here after 17 seconds. If after 5 seconds here I am checking what is the value of concentration, suppose I got concentration 4 mole per meter cube. So in this PFR after 5 seconds this reactant is here. The reactant that you entered from here is here. Here also the concentration will remain same as 4. Here after 10 seconds if concentration is suppose 2.1, here also the concentration will be 2.1. If after 10 seconds these elements again travel this path, and now if this is available at this position after 17 seconds, suppose concentration is 0.8, so here also the concentration will be 0.8. Are you able to understand beta? अभी समझ में आ गया ना? Why they are both are going to give you the same conversion. You will also derive it with the help of numericals. You will also prove it. आप prove भी कर सकते हो. I will prove it. I will show numerical ऐसा हमने लिया हुआ है. Okay अनुष्का बेटा, is it clear? Done? समझ गया ना how I am comparing these two? But for general cases, whenever I am not telling anything, I am telling general case. That means that general case belongs to, there is no non-ideality there. There is no non-ideality there. Epsilon A will be remain 0 there. So these are the general cases. These are general cases. Okay. And also if general case, that means I'm not talking about zero order or negative order reaction here for this case. Okay. So mathematical modeling of PFR. This is your beautiful PFR, but everyone please draw this diagram. This is your PFR. Just a pipe. This is your PFR. Feed enters from here. Product and unreacted feed reactants exited from right hand side. Now volumetric flow rate I am representing V naught, and at the exit side it may be Vf. Sir, V naught will be equals to Vf every time? No, my dear student. This is meter cube per second, and if 1 mole is going to give you 2 mole, and if 100% conversion is going to provide by this reactor, then 100 meter cube will enter. At the exit you will get 200 meter cube. Okay, so how these are going to vary when variable volume I will show you. That is a separate chapter. Okay, so V naught and Vf, I am dealing these things in such a manner so that variable volume case you will be able to handle in very less time. बहुत ही कम समय में आपको क्लियर हो जाएगा step by step, because we are dealing step by step. Okay, and now second one, the concentration here, suppose I am writing CA naught, and here concentration, suppose I am writing CAF, final concentration that you are getting at the exit of the reactor. The molar flow rate of A, FA naught, here molar flow rate FAF. Okay, FA naught and FAF. Can you tell me in which case FA naught will be equals to FAF? Okay, simple reaction I am writing, A is forming R. Can you tell me? क्या समझ सकते हो? Can you tell me, my dear student, in which case FA naught will be equals to FAF? In which case FA naught will be equals to FAF? FA naught FAF के बराबर कब होगा रे भाई, जल्दी बताओ. Tell me. Tell me, my dear students. Initially I am assuming that feed is not partially converted, but if what to do if feed is partially converted? Don't worry, that case also we will handle. First tell me this answer, in which case FA naught will be equals to FAF? जल्दी बोलो. सुस्मित 100% कन्वर्जन, शिवा थ्रो नो रिएक्शन. पूरा एकदम ईस्ट वेस्ट वाला आंसर, 1 0 1 100. एप्सिलॉन ए का भी कोई कॉन्सेप्ट है भाई? नो. नीरज नॉट करेक्ट. मेहना नॉट करेक्ट. Ayush, Shiva Tarun, correct. When no reaction is going to occur there, but A is reactant. If epsilon A is 0, epsilon A is not equal to 0, what does it mean? If even a single percentage of conversion is there, the moles of A is going to disappear. So how moles of A is going to same on both cases? I'm not asking about total moles. Beta, mehna, total moles or for liquid phase if you're writing here, this is moles. This is not about concentration mehna. Be careful. So total moles will remain same on both sides if epsilon A is equals to 0. Total moles. It is not moles of A. A is reactant. When A is moving towards exit, definitely if reaction is going to occur there, A will be decreases. So Fa naught equals to F only. And these type of questions asked in interviews also. So Fa naught equals to FF only possible if there is no reaction is going to happen inside that reactor with A. If A is inert there. If A is inert there. Are you able to understand? Tell me beta, sabhi ko clear hai? Everyone, crystal clear my dear students? Clear sir. चलो बहुत अच्छे. Very good, fantastic, mind blowing, super. Now, because when fluid is moving in this direction, in axial direction, the concentration, the value of conversion, the temperature, anything is can be changed. Or concentration of definitely is going to change in axial direction. Even for isothermal reactors, concentration is going to change. Conversion is going to change. How change? When it moves towards exit, it will increase. Monotonically increase. That means बस बढ़ता ही जाएगा, बढ़ता ही जा रहा है. So that means the we need to take a balance here by assuming some differential element. हमको कुछ यहाँ differential element मानना पड़ेगा ना. So the same differential element here I am assuming. Suppose this is my beautiful differential element. Okay, ये हमारा differential element. This is your differential element. Are you able to understand? This is side view. Side से ऐसा ही दिखाई देगा. ये छल्ला है. Okay, complete. Complete. This is your differential element. This is your differential element. Okay, and I am assuming the volume of this differential element is dv. Dv, differential. D is differential, notation of differential. That dv means if I'm writing different in differential form, I'm telling differential volume. If I'm telling differential volume, that means the volume is very very less. बहुत थोड़ा सा माना है, बहुत थोड़ा सा differential volume. Okay, then definitely from this side, if I am writing the value of fa or A is FA. So here you have to write FA and some change will be there, and I am writing FA plus DFA. Some change. Some change there. Okay. Similarly, you can also write for XA. If here conversion is XA, then after exiting, the value changed by DXA. Now, one interview question. Can you tell me the sign of DFA and DXA here? Sign क्या आएगा? What should be the sign of DFA and DXA here? Interview question. जल्दी बोलेंगे सभी लोग फटाफट. Tell me everyone. Very good, very good. Sushmit Nandi, DFA will be -1 and DXA will be +1 because conversion is going to increase along the direction of flow, and if A is reactant, then the moles of A is going to decrease. Very good, fantastic, fantastic, mind blowing, super. So if you want to show the same graph here on this axis versus distance, अगर इस पे लगाना चाहते हो, so again you can draw this beautiful graph here. Very good, very good, very good, very good. So suppose this show us the exit site So distance traveled, you can write like this. If x naught is 0, then you have to start from here and it will move like this. This is a typical graph that I'm showing you. Okay, this is the conversion. And if you want to see along this distance, what is how to show the value of dxa on this graph? So see beta, this is the value of dxa. So xa conversion plus dxa. Okay, so this is xa versus distance. Now suppose I want to draw here concentration versus distance for this a. For this a, then clearly the a is going to decrease along the distance. So if this is your ca naught and suppose r is not available there, this is cr naught, suppose I'm assuming 0, so you have to start from here. If r is also present in field, then you have to start from here. So nothing is special, it's very easy, normal things. Okay, so the concentration of a is going to decrease along the distance, and at the exit, suppose this is the concentration of a, this is your ca, but the concentration of r is going to increase. The concentration of r is going to increase, r is going to increase along with the distance because r is product. Okay, so these graphs are crystal clear beta, ये सभी को clear है ना? Very easy, it's very easy ना? Can we proceed? Tell me my dear students, can we proceed? ड्रॉ कर लो, ड्रॉ कर लो. Now balance around the differential element of volume dV. Clearly, anytime whenever you are going to write balance, the rate of a into that differential volume dV minus the rate of a, rate, this dot represents rate of a exited from that differential element dV. And you know a reactant, a is reactant here, so clearly a is going to disappear, and you know for disappear here you have to write the rate of disappearance, the rate of disappearance of a within that reactor, and also you have to multiply with volume of reactor. Here I am assuming the volume of reactor, total volume of reactor I am assuming as V. This is total volume, differential element volume is dV. So here you can't write V, here you can't write V, clearly it will be dV ना, ये तो dV होना चाहिए ना. Are you able to understand here? Because you are taking this balance around that volume dV, so you can't write V there. आप वहां पे V नहीं लिख सकते हो. Okay, and that becomes equals to rate of accumulation of A within reactor, within reactor. Now in this beautiful balance, this term will be 0 because accumulation is there, but rate of accumulation is not there because the reactor, these reactors are steady state reactors. The operation that you are going to perform there is steady state. आप steady state operation perform कर रहे हो. So very easy, very easy. Now, what is the value of A in here? It's C. It's Fa. Moles of A in Fa. Moles of A exit क्या हो रहा है रे भाई? Exit is Fa plus DFA minus what is the rate of disappearance of A? It's Ra minus Ra into dV, and that becomes equals to 0. Now you can open this bracket here. So Fa minus Fa minus DFA and minus this minus with Ra is a symbol here. Okay, here we are dealing with this like symbol. Now Fa cancelled here, so you can write minus DFA is equals to minus Ra dV. Okay, minus DFA is equals to these terms you can write in right hand side, so it's Ra into dV. Now you can mention it as equation number 1. आप इसे इक्वेशन नंबर 1 रिप्रेजेंट कर सकते हो. डन, लिख लो, देन वी विल प्रोसीड. Now फोकस ऑन दिस DFA बेटा, इस DFA के ऊपर फोकस करेंगे. DFA actually it is minus DFA. What is FA? FA can be written as FA naught 1 minus XA. FA can be written as FA naught 1 minus XA. And my dear student, this is a valid. Can you tell me validity again? Just I'm checking. आपको याद है कि भूलते जा रहे हो, कुछ रिवीजन चल रहा है कि नहीं? Can you tell me बेटा validity? Very good, valid for all epsilon A. Okay, you know the value of epsilon A can be negative भी हो सकता है, positive भी हो सकता है. Very good. So for all epsilon A, बहुत शानदार. I am very happy. Subject is very important beta. CRE is totally game changer subject in GATE examination. Yeah. Okay, if proper command on this subject, it is alone minimum marks 10 plus. This year 16 plus. क्या बात है भाई. So further moving, I can write as minus Fa naught d of 1 minus xa, because Fa naught is the constant value. This is always initial, shows initial. And again you can write this 1 differentiation 0 xa will give you minus dxa. So I can write minus minus plus. So I can write instead of this dfa I can write Fa naught into dxa. समझ रहे हो? लिख सकते हैं हम लोग Fa naught into dxa in place of this minus dfa. Okay, so now equation 1 becomes instead of df minus dfa you can write Fa naught dxa is equals to minus Ra into dV. Okay, Now it looks like first order linear differential equation of variable separable type. So just rearrange it, integrate it. So how to integrate it? See, dv. First I'm writing here dv. So it's dv and 1 upon fa naught dv, that equals to dxa upon minus ra. You know ra is a function of xa. Now you have to integrate it. When the reactant passes from zero volume, that means it's still not entered in the reactor. So V is when zero. Conversion was, if no partially converted, then here you have to write zero. If partially converted, then here you have to write X naught. After completing complete volume of reactor, if I'm writing the conversion is XA, it is much better if I'm writing XAF. Clearly here you can see, it will give you V minus 0, that means V. So here you can write V by Fa naught, and that equals to Ra infinite number of possibilities for Ra expression, first order, zero order, any fractional order. So R is the function of Xa. So overall, that means we can't write a single universal expression for Ra here. So you have to write expression in terms of Ra. आप Ra के लिए कोई एक यूनिवर्सल इक्वेशन नहीं लिख सकते हो, एक्सप्रेशन नहीं लिख सकते हो, तो इसलिए इस इक्वेशन को हम लोग Ra के फॉर्म में ही फाइनली रहने देते हैं, जस्ट लाइक CSTR. And now this is your final expression, beta. This equation number 3, I think not 3, it's 2. This equation number 2 is known as design equation for CSTR. This is known as okay. बोल रहा सभी को clear? So what next? Next we are going to plot graph. Just wait, saving slides. Till that time you can revise. Now see graph on same slide. And I'm not going to tell you what you have to take on y-axis, x-axis. So please show me your graph. Already these things taught by me. So please draw it and show me. Very good, beta. You can draw for simple conventional case, that is positive order reactions. तो अगर यहाँ बेटा शिवा तरुण, if also you are going to mention that this graph is for positive order, then it's excellent. because for negative order 1 by RA versus that XA will be changed. वेरी गुड सुष्मित नंदी, क्या बात है भाई, क्या बात है। ये एफ ए नॉट का बड़ा ए के सिर पे बैठा दियो जी, नॉट सिंबल में। हाँ अब देखो अच्छा लग रहा है, ऐसे ही खूबसूरती बढ़ती है बेटा आयुष, क्या बात है। ऐसे ही इंटरव्यू क्रैक होता है, जबर वाला, जबरदस्त इंटरव्यू, एकदम गदगद हो जाता है। ओनली दिस सीआरई सब्जेक्ट एलोन, कुछ सब्जेक्ट के थोड़े सपोर्ट के साथ यू विल बी एबल टू क्रैक बार्क इंटरव्यू। आप बार्क इंटरव्यू को केवल इस सीआरई की नॉलेज से क्रैक करने में अपनी प्रोबेबिलिटी को कई गुना बढ़ा सकते हो। वन ऑफ माई स्टूडेंट इंटरव्यूज total time I think nearby 2 hour, and he told me they asked just from CRE for 1 hour। 1 घंटे तक वो CRE से मुझसे पूछते गए मेरे क्वेश्चन को आगे बढ़ा बढ़ा के, ये होगा तो क्या, ये होगा तो क्या, ये होगा तो क्या। ऐसे NPCIL में जाते हो इंटरव्यू देने तो वहाँ थर्मोडायनेमिक साइकिल से वो बड़ा क्वेश्चन पूछते हैं, बिकॉज वो जानना चाहते हैं कि उनकी इंडस्ट्री किस साइकिल पर रन कर रही है, उसके बारे में आपको इन्फॉर्मेशन है कि नहीं है। So other cycles comparison etc, and also they are asking the cycles that is not present in our chemical engineering GATE syllabus in interviews, problems from thermodynamics in NPCI, not in all interviews, in NPCI especially। Very good beta mena, super super। So when you are going to plot here, you have to take 1 by minus R, and you know from where this concept come, from integration, here XA। So the typical graph, just I'm drawing a typical simple graph like this, and this is simply n is greater than 0, and also for defined order reaction the RA expression is not like Kca upon 1 plus Kca, it's simply Kca raised to power n, okay, it's simply Kca raised to power n। So this type of typical graph you will get, and now on this graph, if this point show you here XAF, clearly this is your 0, so area under curve, clearly here area under curve, this area under curve is going to provide you area under curve till XAF is going to provide you the integration value, this dxa by 1 by RA, different integration from 0 to XAF। So what is value of this integral? It's V by F naught, it's V by F naught। So I hope everyone is crystal clear। एसोसिएशन इंटरव्यूज ऑफ टू ऑफ, या बेटा बार के अंदर में जो घटिया से घटिया बच्चा होता है उसका भी 25 मिनट तक जाता है इंटरव्यू, 20-25 मिनट उसको भी 5 सब्जेक्ट से पूछते हैं, 20 मिनट 15-20 मिनट तो जाता ही है। और अगर इफ सिलेक्शन अगर आपका हो रहा है, समझ लो 1.5 से 2 घंटे इंटरव्यू गया, समझ लो सिलेक्शन पक्का है बार के अंदर में। सो क्वेश्चन पूछते जाते हैं, पूछते जाते हैं, पूछते ही जाते हैं, कुछ बच्चों के 2 घंटे से ज़्यादा भी हो जाते हैं, एंड मोस्टली देखोगे मीडियम टाइम, इफ एवरेज स्टूडेंट सो 1 hour नियर बाई, not in all PSUs etc, it's for BARC, BARC, भाभा एटॉमिक रिसर्च सेंटर। वहाँ इंटरव्यू बहुत खतरनाक होता है, बिकॉज इवन इफ यू गॉट रैंक 1 and other non-GATE qualified student, and if interview of that disqualify in GATE student good than rank 1 student, they are not going to select that rank 1, they will select the student जो क्वालिफाई भी नहीं हुआ था गेट में, उसको सेलेक्ट कर लिया, वो इवन नॉट डिडंट क्वालिफाई गेट एग्जामिनेशन, बिकॉज इन BARC the initial recruitment, how to call for interview, two separate paths are there, you can choose any one path, or you can choose both paths, in both paths that means pass, in any one pass still you pass, दोनों में से किसी एक पाथ में आपको पास होना होता है, दोनों में पास हो तब भी पास हो, किसी एक में पास हो तब भी पास हो. दैट इज सेपरेट रिटन एग्जामिनेशन फ्रॉम BRC side. And second, with the help of GATE, that respective year GATE examination, according to that they will also give you cutoff. Okay बेटा सुष्मित, चलो तो यहाँ तक क्लियर है सभी को. कैन वी प्रोसीड? Very very easy. Now the beautiful thing is, you know, again here if you want to write space time, that is tau, for PFR, no need to worry here. Again the definition will remain same, V by V naught. If someone asks you space velocity, because this is also a continuous flow reactor na yaar beta, this is flow reactor, space time, that is SPFR, no need to worry, it's V naught by V. It can be written as 1 by S PFR, or it can be written as 1 by tau PFR. So if it's still same beta, the design equation that you had seen V by FA naught, so we can write V by FA naught as V by, what is FA naught? This was V naught C naught. That means we can also write tau by C naught here. We can also write this as tau by C naught. So the final design equation that you can write here, V by FA naught equals to tau by CA naught is equals to XA naught is equals to 0 to XF. Why sir you are writing XA not equals to 0? Because if XA naught is not equal to 0, then you have to choose XA naught there. ये आपको बता रहे इनिशियल लिमिट लेते हैं, बहुत बच्चा इसी में कंफ्यूज रहता है. Many student confused in initial limit, what to take it. Okay, if some conversion is also there, and if suppose that PFR is going to followed by CSTR, then clearly at the inlet side some conversion is still there, some conversion already are done in this cumulative nature. Okay, so dxa upon minus RA, and this is valid for epsilon A. Which epsilon A, can you tell me? Can you tell me? Can you tell me? Can you tell me beta? Very good, very good, very good. And in this expression again, my dear students, this V is not a function of, you cannot change this V. This is the volume of reactor, not reaction mixture like in batch reactor. So in this whole design equation, this is the one that can be written for this case or can be written for this case. Okay, for both cases. And also it is going to depend for these both cases that the reaction is liquid phase or gas phase here. If liquid phase here, then you know, even if epsilon is not equal to 0, the thing is not going to become difficult for you. But for gas, it is going to become difficult for you. These all cases I will discuss separately, as already I told you. Sir, how can we determine this validity? Because beta, here this V is the volume of reactor, you know, this can't be changed. आपका reactor क्या अपने मन से फुल जाएगा, पिचक जाएगा? It is going to expand or contract? No. Reactor volume is fixed. If you are going to purchase a reactor from the market, volume is fixed for that reactor. The second thing, Fa naught, already this is the number of moles of A. So clearly it is also not going to depend. So out of these all equations, what is that? This is Ra. So R is equal to KCA, and concentration. In concentration, one term is there, mole per meter cube. Meter cube is volume. And for gas phase reaction, if moles are increasing or decreasing, for same given pressure, the volume can change. Volume will change. Okay, beta? Kya Dash? Sir, why we can't take V volume of reactor in batch? Beta, in batch reactor, when you are dealing things, volume of reactor can be written as volume of reaction mixture for homogeneous system. वहां भी माना जाता है अगर homogeneous system है. For heterogeneous you can't assume. Okay, but the most important thing, which one is more accurate? क्या more accurately हमारे मुंह से कहा जाता है? क्या एक्चुअल में होता है. सो इन बैच रिएक्टर द एक्चुअल थिंग इज वॉल्यूम ऑफ रिएक्शन मिक्सचर, because that is simply close batch reactor. If something is going to some moles are going to form there, then they can give little bit more reaction mixture volume. So that's why बेटा वहां पे हम लोग रिएक्टर के वॉल्यूम को नहीं लेते, क्योंकि फ्लो में नहीं ना कुछ. अब यहाँ फ्लो में तो पूरा का पूरा देखो, सी इफ दिस इज इन फ्लो, नो पार्ट ऑफ दिस पाइप कैन बी एम्प्टी, no part of this pipe can be empty. But batch reactor, any size you can make, because this is not continuous reactor. Any size you can make, because nothing in, nothing out during reaction. CSTR also in, out every time it is going to happen. Okay, is it clear, beta Ayush? So इसलिए बैच रिएक्टर के अंदर हम लोग रिएक्शन मिक्सचर को देखते हैं. और यहाँ पे हम लोग V जो है कैपिटल, ये बहुत ज्यादा इंपॉर्टेंट टॉपिक है, बहुत सारा बच्चा इसमें कंफ्यूज रहता है, पूरा लाइफ टाइम कंफ्यूज रह जाता है. Okay, so V you can't change V here, because that capital V is the volume of reactor, and volume of reactor can't be changed by you. Volume of reactor आप change नहीं कर सकते हो. Okay, so here also we can write it becomes equals to tau by Ca naught, tau by Ca naught. इसको हम लोग tau by Ca naught के बराबर भी लिख सकते हैं. Okay, ओके रिवाइज करो. जस्ट एक क्वेश्चन छोटा सा टाइप कर रहे हैं, लिख रहे हैं आपके लिए. इट शुड बी क्वेश्चन नंबर आई थिंक 99. या प्रॉब्लम नंबर 99. Just revise. I will show numericals in few time, after few time. 70%. Okay. चलो बेटा सॉल्व करें, प्लीज सॉल्व इट. Whenever no non-ideality data is given, that means you are going to do these things for ideal CSTR and ideal PFR. That's why here I'm not writing ideal CSTR or ideal PFR. क्वेश्चन नोट कर लिया बेटा? चलो 2 मिनट की स्लाइड हटा दिया. Solve it. Now few questions we are going to practice here. From CSTR as well as from PFR. Once done, just inform me, beta. Okay, Anushka. बहुत अच्छे बेटा। नीरज बेटा, शिवा तरुण, first comment will be your final answer. So why you give an answer in unit, in minute? You give answer in minute बेटा, क्यों मिनट में दिया? हम्म? बहुत अच्छे बेटा। Problem is very easy बेटा. So for an isothermal batch reactor, 70% of a liquid reactant is converted in 30 minutes. Very good. That means first you have to deal this for batch reactor. Okay. So in this batch reactor, if the time is 30 minutes, then the value of conversion is 70%. Now, what space time and space velocity needed to achieve this conversion is a CSTR and PFR. So, beta, when you are writing for CSTR, so here you have to write the value of tau. What is the value of tau here? And what is the value of yes? Here, once you got the value of tau, reciprocal will be S. And the conversion you need same. That means 0.70. So, this is one question. And one you have to solve for PFR. So, if you are dealing this in PFR, then what will the value of tau and S? And again for same conversion. Okay, clearly liquid reactant is there, that's why reaction is not required. Epsilon A is not going to affect your rate expression. So CSTR, you know, design equation is tau by C naught equals to XA upon minus RA. First order, so you can write K CA. Further moving, tau can be written as CA naught into XA upon K CA. Fantastic here. So what is the value of CA naught? You know the value of CA naught here. No, you don't know. But first order, so no need to worry. See, denominator CA can be written as CA naught 1 minus XA. C naught cancelled. So it's XA upon K1 minus XA. Oh my god. K is not there in our question. Now how to get it? That's why one more data is there for batch reactor. So you know for batch reactor, the first order, I already told you to increase your speed. You can remember few important equations that you are going to use in multiple times. Like for first order, this was our final expression. C is equal to C naught e raised to power minus kt, or minus ln of C by C naught is equals to kt. So you need the value of k, so no need to worry here. K is equals to minus 1 by t, and ln of Ca can be written as C naught 1 minus xa. So C naught cancelled, it's just 1 minus xa. How much time? It's 30 minutes. And ln of 1 minus, what is the value of xa? It's 0.7. Just solve data. Can you tell me the value of k? K कितना आया आपका in minute and verse? Tell me the value of k in minute and verse, beta. In minute and verse. I'm asking in minute and verse. Minute inverse में कितना आया? I 0.04 आ रहा है, कंफर्म हो? Okay, very good. So it's 0.0401 minute inverse. Okay. Now the same value you can use here. So what xa? Xa is 0.70 upon 0.0401 into 1 minus 0.7 will give you 0.30. Can you tell me what is the value of tau here? Tau कितना आया? Tau CSTR minute inverse में 58.33 minute inverse. Or divide by 60 and tell me answer in second. Sorry, not minute inverse. Oh, it's minute na yaar. It's tau. Tell me in second, just multiply with 60 and tell me, because I asked in second. 3500 second approx. Okay, 3500 second. So this is your one answer. And what is the value of yes CSTR? No need to worry, just 1 by 3500 in second inverse. 0.0172. ओके, ये तो मिनट में बता रहे हो ना, सेकंड में बताओ, बिकॉज आस्ट इन सेकंड इनवर्स, सो डायरेक्टली रेसिप्रोकेटेड. ये बहुत छोटा आ रहा है ना, इसको एक काम करो, इसको मिनट इनवर्स में रहने देते हैं. So it's 1 by 58.33, and as you told me 0.0172, 0.0172 minute inverse. So these answers for CSTR. Can you tell me for PFR? PFR के लिए कितना आया बेटा? For PFR, can you tell me, my dear students? You have to use design equation. tau by Ca naught is equals to 0 to 0.70 dxa upon minus Ra, and minus R can be written in case Ca, and Ca can be written as Ca naught 1 minus Xa. C naught cancelled. So tau is equals to 1 by K. Here you can take common, and 1 minus 0 to 0.7 dxa upon 1 minus Xa. Further moving, you know the value of K. Put कर लेना यार. Integration will give you ln of 1 minus Xa, and because 1 minus Xa is there, so minus will also come here. Clearly you can see the final expression same as batch reactor. अब समझ गए? यहाँ देखो proof equation से भी prove हो गया. From equation also you can prove that tau will remain same here, as you had seen in the case of batch reactor. If you are giving same time both places, then the value of conversion will remain same in both places. 0.0 कहाँ गया? 0.0401 and ln of 1 minus 0.7, it will also come same to same 30 minute, or you can say 1800 second. And what is the value of yes? It's 1 by 30 minute. I think it will be 0.0333 minute inverse. बोल बेटा, सभी को क्लियर है? Everyone crystal clear, no doubts? चलो बहुत अच्छे, very good. Now problem 99 900. Now see 101 from CSTR 1990 2-mark question. What is the exit conversion of reactant A for a zero order reaction taking place in a CSTR with the following data? Feed concentration, feed flow rate, everything is given there. Reactor volume is 1 liter. जल्दी बताओ. Time started. Very good beta. Shanmuga Priya, very good. Last 20 seconds. Very good. So the problem is very easy, my dear students. Exit conversion of reactant for a zero order reaction taking place in a CSTR. Zero order, that means the Ra expression can be written as just K. Rate constant is also given. 1 mole unit is very important, so be careful during GATE examination beta, or any examination. Feed concentration, so it's clearly Ca naught, that is 1 mole per liter. Feed flow rate, that means V naught. For any question बेटा first you have to extract data. आप सबसे पहले data extract करोगे in examination. Okay, so V naught is 0.5 liter per minute. Reactor volume, that means capital V, is 1 liter. Now you know design equation for CSTR, that's V by FA naught equals to XA by minus RA. Now just put values. V is 1 liter, okay, in liter. FA naught converted as V naught into CA naught. So V naught into C naught, liter cancel, mole per minute. Okay, so mole per minute here we are getting, and here liter. So mole, minute, liter, okay, consistent. कोई भी conversion requirement, no need of any conversion here. Units are consistent with each other. That equals to XA we need to write, and it's equals to R is equals to K, and K is 1. So clearly, my dear students, the XA value that you are getting here, 1 by 0.5, that's 2. So clearly the answer is 200%. Are you able to understand which one is the right answer? It's D. Is it D? No, it's not D. It's C. Because the max conversion, okay, the max conversion that is possible is 100%. So it can't exceed 100%. Okay, so correct answer is C, that is X is equals to 1. Now how to further analyze this question? इस क्वेश्चन को और ज़्यादा एनालिसिस करके हम क्या जान सकते हैं? Because clearly here you are getting conversion 200%. So can you tell me, if you are in an industry and such a reactor this time you are using, so what you are going to do? आप अभी क्या करोगे? And on what side you feel some losses there? Can you tell me, my dear students? अरे यार स्लाइड बढ़ाए तो स्लाइड कहाँ गायब हो गई रे भाई? ओके, अभी बढ़ गई वापस से. So my dear students, see, you used this size of reactor, okay, whose volume was 1 liter. So just change it. Very good. Is the class over? No, beta. Are you not able to see me? Am I visible to all of you? देख पा रहे हो हमें ना? Audio video crystal clear? Yes sir. Okay beta, Priya is still I think 30-minute class is there. Okay, just focus here. So if you want to change it, you have to change here it from some other reactor having the volume less than, here the volume should be less than 1 liter. Why? Because 200% conversion is not possible. That means uh, this is totally not good for you, that you are going to give extra time there inside that reactor, because reactant already converted and still that is in the reactor. That is not good. This is your killing time, and time is money. So clearly you have to change it. So in your examination, one more question they can frame it. See, so this is 101. See problem number 102 here. Problem number 102 here. What volume of CSTR required for 100% conversion here? If someone asks like this, then what to do? अभी क्या करोगे यार? How to perform it? So clearly This time again, when you are going to write V new by Fa naught, and Fa naught is V naught C naught, so it's 0.5 into 1, 0.5 into 1, and that equals to, this time XA here that you are writing, या put, see अभी solve कर रहे हैं क्या होता है, see during solution what will happen, so just see here. So XA will be 1, and by RA is just K. That's good. So Vn here will be 1 into 0.5 upon K. And what was the value of K? It's 1. It's 1. So clearly the volume will be 0.5 liter only. Are you able to understand? Now, again they can ask you in interviews. In interviews. Is it possible? Now you have to tell me yes or no. Is it possible? Here for this case, is it possible? Tell me. Jaldi बताएंगे. Everyone, please tell me. Is it possible, my dear students? Still waiting for your comments? If don't know, then you can write R in comment section, beta. Don't know? Tell me. Still waiting for your comments. Possible, but it will take long time to achieve steady state IUs. Mehna sir, can you repeat the question? But I asked you, uh, when we are taking 0.5 liter CSTR, then is it possible in industry, even if it is ideal one? So is it a possible case that we can deal? I think no, sir, because volume should be more compared to 100% conversion. Support your answer, beta. Support is not well enough. I'm telling you, CSTR is okay. CSTR is ideal one. Even in ideal CSTR. Don't know. So the right answer is yes. Here, yes. But again, interview. Again, I'm asking interview. If, again, interview question 2. If order is 1, is it possible? Is it possible case in industry? Even we are assuming ideal CSTR. No need to worry. Ideal CSTR in both cases. Here I am telling yes, possible. Yes, for this case it is possible. But now again you have to tell me why it is not possible this time. Why is it not possible? It is not possible. Everyone telling this time no, no. Why? Previously you unable to give answer, but this time you are telling yes. No, no, no. Everyone giving. No. Can you tell me why? Okay, conversion never in one. Okay, okay. I'm changing. I'm changing order. 1.5. I'm changing order to 3. Now, tell me. I'm changing order to 0.5. Now, tell me. Mhm. Yeah, beta, Priya. Very good. Conversion also increases. But I am asking here, if the order is first, then 100% conversion you are going to achieve in CSTR. You are going to achieve in CSTR. Is it a possible case in industry? Still, I'm not getting any satisfactory answer. High residence time. Okay, beta, Shanmukh Priya. Other students, please tell me. Still, I'm not getting satisfactory answer. That's why in interviews many times asked. Don't know. No, just focus here, beta. Clearly, this time the answer is no. Why? Why no, sir? See. In previous case, it was 1 because na the concentration here will remain same as here. No, sir, because complete conversion we cannot achieve in finite time. No, beta, man, this is also not answer. The correct answer here in this case is even you can write for PFR, sir, use infinite length. For that case, it is possible. You can write now. Mehna. Definitely, you are able to give answer that is infinite length. For infinite length, it is possible. For DA become infinity for X7. See, wait, Anushka, Viswas, and everyone. If this is the case, and if you are telling XA is 100%, that means this CA is 0, beta. And if this you are writing KCA, suppose, so rate is 0. Oh, what is this, yeah? Every time inside reactor you are telling nothing is going to happen. Are you able to solve it? क्या इसे सॉल्व कर लोगे आप यहाँ पुट करके कुछ लगा लोगे? So the right answer is no in industry. And again, if you make it possible, if you want to make it possible, then the constraints will be nearby possible. Then constraint will be very, 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 very low, nearly zero for nearly infinite volume reactor. समझ रहे हो? Here in denominator it will be zero now. It will be zero now. So this tau becomes infinite. So no, it is not possible to achieve that zero there, because if you are achieving zero for ideal case, then inside that reactor the concentration will also be zero, and now rate is going to depend upon concentration also. Here it is not going to depend. Here just Ra is equals to K, so concentration independent. This is concentration independent. The rate is totally here controlled by K. यहाँ K के द्वारा कंट्रोल हो रहा है. That's why here you are getting it just by using that reactor volume 0.5 meter. It's not required in finite in this case. Okay, यहाँ पे finite पे आ जा रहा है because the reaction order is 0. But my dear students, here if this is the case, then see V by FA naught is equals to XA upon KCA. And if CA you are writing 0, that means XA by 0 or XA is 1 by 0. See, it's infinite, beta. It's infinite. So clearly no if no for any finite reactor. It is not possible. Okay? Is it clear to all of you? सभी को क्लियर हो गया? चलो इसे सॉल्व करो। You can write for 99.9%, 99%, but not for 100%. You can't be able to handle for 100%. So beta, here in previous question again I want to discuss you, that was an exception case. वो एक exception case है, इसलिए पूछा जाता है zero order reaction का, because rate is independent on CA, and clearly for that case, for finite V you will be able to achieve that value with the help of design equation. Because instantly the reactant is going to in there, immediately converted to the product, and still the rate is there. So numerically here you will get not infinite case for a zero order reaction. Very good. Correct answer is 1.816. See beta Anushka. Sir, can you explain it one more time previous? See beta Anushka. No problem. Here, if the reaction order is not zero here, if it is going to depend upon that concentration, then clearly you can see beta. Here when you are going to put it Ca, then this Ca will be equals to 0. KCa. Then Ca will be equals to 0 here. And if Ca you are putting 0 here, because 100% conversion here, 100%, that means here if Ca naught, so what is Ca? Ca is Ca naught 1 minus Xa. If Xa is 100%, then clearly you can see it is 0. Ca naught into 1 minus 1, that is 0. So clearly you, if for 100% conversion inside that reactor the concentration is 0, that means there is no rate, कोई conversion हो ही नहीं रहा अंदर, because R is equals to 0 here, because you are using this expression, R is 0 here, because it is going to depend upon Ca. But for zero order reaction, It is Ra is K. It is not Kc. It is K only. So even after putting C is equals to 0, it is going to give you some rate there. Are you able to understand better? So exceptional cases, yes, zero order reaction is exceptional case. Zero order is exceptional case. Okay, got it, sir. Very good. So here, absolutely correct. 1.815. What 816 is the right answer. So 10 meter CSTR is there. 10 meter cube CSTR is there. Used to decompose the dilute solution of a decomposition is irreversible with first order. So irreversible with first order, I can write A is forming R. So I can write Ra, and I can write that equals to K into Ca. And rate constant is also given. The value of K is also given. 3.45. Our inverse. 95% decomposition, that means 0.95. Now the required feed rate is, so unit is not there. So suppose they are asking in required feed rate in meter cube per hour. Suppose they are asking in meter cube per hour. So how to solve it? It's meter cube per hour, that means V naught, V naught. So V by V naught Ca naught, this form we are going to use, and CSTR, so no need to worry, Xa upon minus Ra, and minus Ra is clearly K Ca, and Ca is Ca naught 1 minus Xa. Ca naught cancelled. V naught can be written as K V 1 minus Xa and whole upon Xa. What is the value of K? 3.45. What is the volume? It's 10 meter cube. And how much conversion required? 95%. So 0.95 Xa. 0.95. After solving it directly, you will get 1.816 meter cube per hour. After cutting unit, you will get it, because you used meter cube for volume. Okay, all clear? Now question number 104 and 105 is very good question here. Very good question. In 1991, the rate of a liquid phase reaction of the type A plus B forming product, it is found to be independent of concentration of A and B and equal to 1 kilomole per meter cube per minute at 300 Kelvin. Find the conversion in the mixed flow reactor having volume 2 meter cube with feed concentration of A and B equals to 5 kilomole per meter cube, feed flow rate equals to 1 meter cube per minute, and reactor temperature equal to 300 Kelvin. Now, if the activation energy of the reaction is given as 83.1 kilojoule per mole, find the volume of the isothermal plug flow reactor for the same conversion and feed conditions as in the case of the above mentioned reactor, but with the reactor temperature now this time 320 Kelvin. Very good question. And similar pattern now going on. This is some जो difficult question बन रहे हैं, इसी तरह के similar pattern पे बनाए जा रहे हैं. Similar pattern in last 5 year you can see 2022, 23, 24, 25, similar pattern. So very good question. This time if you are able to solve it, then very good for you. I'm a starting timer here. Come on, बहुत आसान है. It's very easy. Come on, beta. Only 10 minutes left in today's lecture, so please solve it little bit in faster manner. दोनों आंसर एक साथ दें. Mixed flow reactor is also known as back mix reactor. मिक्स फ्लो रिएक्टर को हम लोग बैक मिक्स नाम से भी जानते हैं. लास्ट 30 सेकेंड. चलो ध्यान दो बेटा। जस्ट एडिंग फ्यू क्वेश्चंस टू योर होमवर्क। होमवर्क में कुछ क्वेश्चन बढ़ा रहे थे। नो आई होप enough time given by me. The answer A, 0.220%, I think it was 40% आना चाहिए। I will solve it again. It आंसर कीज में 40% लिखा है हमारे पास, एंड फॉर सेकेंड वन इट शुड बी 0.249 मीटर क्यूब। आई विल चेक इट अगेन, डोंट वरी। एक बार फिर से चेक कर लेते हैं। चलो